Okay guys, welcome back to your lesson 1.3 for Algebra 2. This is video number 2, our second and last video. Example 3 is standardized test practice, and so it will be practice for you, not just for this class, but also for tests like the PLAN, which is the kind of like the PSAT for the ACT, and then the PSAT and the ACT. So it's good practice. So what is the solution of 7p plus 13 equals 9p minus 5? Okay, so our first step is going to be to write the equation, always to write the original equation. And you kind of want to think about what's in the original equation. You've got 7p plus 13 equals 9p minus 5. So you have variables on both sides of the equation. Okay, you want to get all your variable terms kind of gathered up on one side of the equation and the number terms on the other. So we want to go ahead, we're going to subtract 7p from both sides. And so that's going to give you 13 equals 2p minus 5 because 9p minus 7p is 2p. Now we want to get the number terms on one side. So we're going to add 5 to each side, and that's going to give you 18 equals 2 times p. All right, p is being multiplied by 2, so to undo that, you want to divide each side by 2, and that's going to give you 9 equals p. Okay, so to that, we look at our answer choices and we go, great, our answer is D. All right, now one thing you need to know, because sometimes students are like, well, if our answer is one of the answer choices, why do we need to check it? Well, the people who write standardized tests are really, really smart, and their distractors come from common mistakes that students make. And so students will make one of those common mistakes, work the problem, and they'll see their answer as one of the answer choices, and they won't check their work. And so they're confident, but wrong. So you want to check your work just to make sure that you didn't make a mistake, that you do have a correct answer. Now remember, the principle here is that you want to plug in your value for your variable and get the same number on both sides of the equation once you simplify. You want your equation to be equal. You want both sides to be equal to each other. So you can write out the original equation and note that everywhere that we have a p, we're going to plug in our solution. So there's 2 places where there's a p, so there's 2 places where we're going to plug in our solution. Right here where we have 7 times p, and right here where we have 9 times p. All right, so we're going to substitute 9 for p. So that's going to give us 7 times 9 plus 13 equals, maybe, maybe not. That's why I've got the little question mark there. 9 times 9 minus 5. So we want to do our multiplication. So 7 times 9 is 63 plus 13 equals, maybe, maybe not, 81 minus 5. Well, 63 plus 13 is 76. 81 minus 5 is 76. So our solution checks. So 9 is our solution. When we plug it in, we have 76 on both sides of our equation, so we have a true statement. All right, moving on to example 4, we're going to solve an equation using the distributive property. So we're going to solve the problem 3 times the quantity 5x minus 8 equals negative 2 times the quantity negative x plus 7 minus 12x. So write the original equation, and then we're going to distribute. Okay, so we're going to do 3 times 5x minus 8. So 3 times 5x is 15x, and then minus 3 times 8 is 24. On the right-hand side, we're going to distribute the negative 2 to the negative x plus 7, and then we'll subtract the 12x in just a minute. So we're going to do negative 2 times negative x is 2x, because negative times negative is positive. Okay, we're going to do a negative 2, and then we have times plus 7, so negative 2 times 7 is negative 14, so we end up with minus 14, and then we have our minus 12x. Okay, so before we start moving anything from one side to the other, we want to make sure our individual sides are simplified. So at this point, we want to combine like terms. 15x minus 24 is good to go. There's no terms to combine, but on the right-hand side, we can combine the 2x minus 12x, and 2x minus 12x is negative 10x. So we've got 15x minus 24 equals negative 10x minus 14. Now we want to start gathering up our x terms on one side and our plain number terms on the other. So I'm going to add 10x to each side. and that's going to give me 25x minus 24 equals negative 14. And now I'm going to add 24 to both sides, and that's going to give me 25x equals 10. Well, this is 25 times x equals 10, so we're going to divide both sides by 25, and we're going to simplify. Now, initially we get x equals 10 over 25, but that reduces by a factor of 5 on top and bottom to 2/5. So x equals 2/5 is our solution, or at least we think so. We need to go back and plug it in and make sure that we get the same value on either side of the equation. So we're going to plug in 2/5 everywhere we see x. All right. So we're going to substitute 2/5 for x. So that's going to give us 3 times the quantity of 5 times 2/5 minus 8 equals, maybe not, negative 2 times negative 2/5 plus 7 minus 12 times 2/5. All right, so we're going to simplify. All right, here we've got 3 times negative 6. The question is, well, where did the negative 6 come from? Where did the fraction go? Okay, well, let's think through this. 5 times 2/5, the 5's will cancel, and that'll leave us with 2. Minus 8 is negative 6. So that's where we got the 3 times negative 6. Now, on the right-hand side, we could add the negative 2/5 plus 7 together, or another way, if we feel like this is a simpler way to do things, is we could distribute the negative 2. The distributive property still holds. So just to practice that, let's go ahead and do that. So negative 2 times negative 2/5. Negative times negative is positive. 2 times 2 is 4 over 5, so we've got 4/5. Now, we need to distribute that negative 2 to the 7, and so negative 2 times 7 is negative 14. So once again, we've got minus 14. Okay, now we need to do the minus, and then 12 times 2/5. 12 times 2 is 24 over 5. So we've got that minus 24/5. Okay, on the left-hand side, it's pretty easy to go, okay, 3 times negative 6 is negative 18. On the right-hand side, let's think through this. 4/5 minus 24/5 is going to give us negative 20/5. Okay, negative 20 divided by 5. So negative 20 divided by 5 is negative 4. So negative 14 minus 4 is going to give us negative 18. So we get negative 18 equals negative 18. All right, so let's apply this, okay? We're going to apply this to solve a work problem. All right, it's car wash. Let's say you're trying to raise money for some group and you're washing cars, or you're doing it for a service project, and you're working with a friend, and you know it takes you 8 minutes to wash a car, and it takes a friend 6 minutes to wash a car. How long does it take the two of you to wash 7 cars if you work together? All right, so there's 7 cars, and you need to know, well, how long is it going to take us to get these 7 cars done? All right, so let's talk about our solution. One thing that you can do, if it's helpful to you, you can write out a verbal model before you write out an equation. So for a problem like this, you want to go, all right, we're going to work some amount of time. I'm going to work the same amount of time that my friend's going to work, but we work at 2 different rates. So you're going to think about how much you're going to get done in that time and how much your friend's going to get done in that time. However fast you are at doing a particular job, in this case it is cars per minute. You're washing so many cars per so many minutes. And so that's your rate. That's how fast you can get the job done. Times the total amount of time that y'all are going to spend working, plus your friend's rate, in this case cars per minute, times time, and that's going to equal the number of cars washed. Okay, which is just going to be cars. So the total number of jobs, whatever job you're talking about, that's going to get done. Okay, so your particular rate is you get 1 car washed every 8 minutes. Okay, and you and your friend are going to keep washing cars for however many minutes it takes. So that means our variable, let's use t because we're talking about time, so times t minutes, plus your friend's rate, which is going to be 1 car for every 6 minutes, times the same amount of time, so times t minutes, equals 7 cars. Okay, so you're going to work for T minutes, your friend's going to work for T minutes, and that's going to get 7 cars washed. The question is, what's T? Step 2 is just write the equation for T and solve it. Solve the equation for T. So we're saying 1/8 T plus 1/6 T equals 7. Now, we could get a common denominator and keep working with fractions on the left-hand side, or we can determine what the common denominator would be and then multiply both sides by that number. So our least common denominator, we're working with 8 and 6. 8 times 3 is 24, 6 times 4 is 24. So our least common denominator is going to be 24. So we're going to multiply both sides of the equation by 24. Now, on the left-hand side, that means we're going to need to distribute. On the right, we're just going to need to multiply 24 times 7. So we're going to have 24 times 1/8 T plus 1/6 T equals 24 times 7. So we're going to distribute the 24 to 1/8 T and 1/6 T. So 24 times 1/8 is going to give us 24 over 8. 24 divided by 8 is 3. So we get 3T plus 24 times 1/6. That gives us 24 over 6, which is 4. So that's 4T equals 24 times 7 is 168. So let's combine terms. So we get 7T equals 168. Well, that's 7 times T equals 168. To undo the 7 times T, we're going to divide by 7. And so that gives us T equals 24. So it will take 24 minutes to wash 7 cars if you work together. That's pretty good. Now, let's just double check. This one we're going to kind of logic through it. Okay, we're going to kind of go, all right, so we're washing cars for 20 minutes. So you wash 1 car for every 8 minutes, and you keep going for 24 minutes. So 1/8 times 24, you're just plugging in 24 into time, multiplying your rate times time, and we get 1/8 times 24, that's 3. Your friend washes 1/6 times 24, which is 4. And so this was in 24 minutes. We plugged in 24 for the amount of time. Together, 3 plus 4 is 7. So together you wash 7 cars. So that works out. Okay, that is the last example. You'll notice you have several problems to try on your own. You are expected to have those done each day when you come into class. After you've watched videos and taken notes, you are expected to apply what you've seen just to kind of help cement it in your brain so that you remember how to do it. When you come into class, you'll show me that you've completed your notes. I'll check that they're done, and then you'll get your notes back. It'll be a real quick process. I'll just kind of, I'll put a check mark on your paper, record your points for it, and then we will go over those problems that you tried on your own as the warm-up of the class to kind of get you back into the Algebra 2 mode and thinking about what you did on the video. Okay, well, next thing you know, we'll be doing our first set of rounds for section 1.3.